Good morning and good evening, everyone. Thank you very much for joining us today as we showcase Zesty Disk, our new autoscaler for EBS volume. So Zesty has been around for about 2.5 years, and our mission is to create a new cloud experience for DevOps teams. A brief introduction, my name is Ido, and I'm leading the marketing here at Zesty. I've been in the company for almost 1 year. Today, I'm very proud to have with me Alexei, our CTO, to walk you through the demo and answer any questions you may have. A quick overview of the agenda for today. We'll talk about the current challenges of scaling EBS volumes and how Zesty Disk addresses these challenges. And afterwards, Alexei will do a full demo of the Zesty Disk platform. And finally, we will leave about 10-15 minutes for Q&A. All right, so the challenges of scaling EBS volumes. None of us want to wake up in the middle of the night discovering production outage due to insufficient disk space. That's why engineering teams such as yourselves tend to provision much more space than needed. Typically, we witness about 70% overhead on provisioned disk storage. In addition to that, as the application evolves, the storage requirements can change and fluctuate during different hours of the day. For example, periodical tasks that are heavily dependent on disk. So every DevOps engineer's dream is to have the cloud adjust itself to the application needs automatically. But this is how typical provisioning looks like in our reality. A lot of unused storage. In order to achieve continuous monitoring and optimization, you need visibility into your storage environment. To gain that visibility into your EBS costs and those EBS utilization, companies implement monitoring tools which require them to configure monitoring thresholds, investigate each alert to make sure it's not a false alarm, take action and extend the EBS volume in AWS, and eventually wait until it's ready to use, and then extend the file system on the instance to allocate the new provisioned space. All of these actions are very time-consuming and require 24/7 attention to alerts. I'm sure that some of you have woken up in the middle of the night needing to extend your EBS volumes. So once we have expanded the disks, AWS limits the users, allowing them to extend the disk once again only after 6 hours. So you really need to measure twice and cut once because you will not be able to extend the disk within these 6 hours lock. In addition to that, extending the EBS volume is a one-way ticket. You can't shrink the disk back. This limitation is caused by the fact that data is written randomly to all of the disk sectors and you can't revert back to a smaller size without losing data. This is the biggest limitation we have today. Now, all of this was true until today. We're super proud to announce the launch of Zesty Disk, our new auto-scaling solution for EBS. So Zesty Disk will automatically shrink and expand EBS volumes according to your real-time usage, eliminating the need for capacity planning, monitoring, and management. And as a result, you will benefit from significant cost savings on your EBS spend completely hands-free. Zesty Disk solves all of the problems we discussed earlier, providing comprehensive visibility into your file system utilization, continuous monitoring, and true elastic provisioning, so you no longer need to plan capacity ahead. With Zesty Disk, you can start with a minimum amount of disk space and gradually and automatically scale the disk according to the application's real-time consumption. So right now, I'm heading the microphone over to Alexei to shed some more light on the technology and how it's built behind the scenes. Alexei?
Hey guys, so thank you, Ido. Sounds very promising what you just told us. So just a second before we jump into the live demo and seeing all this concept in action, I want to start by just some simple concepts we all know, and I think any typical EC2 instance you're familiar with will have a file system, first of all. Let's assume it's 100 GB in size and it's behind the scenes backed up with an EBS volume that is attached to an instance. Now, as we discussed earlier, this approach has so much limitations. You have only one way of extending the existing disk, extending it one way with a lock of 6 hours, and you can never go back. Now, in Zesty Disk, we took absolutely different approach. I think it's very similar to a well-known EC2 auto-scaling group, where we combine resources to accommodate to a demand changes. So instead of provisioning one single EBS volumes, we actually make the file system flexible as a Lego blocks. Now, this actually allows us to create and actually aggregate more than one EBS volume, combining one single file system. Now, by taking this approach, Zesty Disk can be lightning fast by scaling up, by adding additional EBS volume once it's needed, and also vice versa. When the requirements from the storage is going back and we don't longer need all the provisioned size that we actually paying for, Zesty Disk can safely detach and remove any of those small blocks to achieve an optimal resource utilization at any time. So actually this is possible due to a copy on write technique that we use behind the scenes, powered by BTRFS, that allows us to redistribute data blocks stored on multiple physical devices or EBS volumes and safely remove unused capacity while not interrupting the read and write operations of the file system without any downtime, without any impact on the application. Now, while we understand all the theory, I invite you to go with me to the AWS console and see this in action. What we are going to do is, first of all, let's provision a new instance. I think some small instance will be fine for the demo purpose. Let's go ahead. Now, at this stage, actually, in order for us to get a real visibility into what's happening in the file system, because this metric is absolutely absent in CloudWatch, we have no idea how much out of the provisioned disk size that we are paying for is really being utilized. So first of all, in order to get this, we allow, and I will double check on the, double click on the dashboard and show you all the features we have in the Zesty dashboard. First of all, we need here is take the agent installation script that we need to copy. This is very simple bash script that install the monitoring agent that will be our eyes into the file system and into the usage of the disks inside. Now, let's go ahead. At this stage, as a best practice, we want to separate our operating system and leave the root volume as a default 8 GB and actually add another EBS disk. This one will hold our application data. Now, it's good because actually combining both the application and the root volume, making our operating system and the application actually fighting for the same resources and interrupting each other, which we don't want in our production systems. Now, I want to make sure to also terminate this volume once the demo will be done, so we'll not leave any unused disks out there. Let's assume, I think 15 GB will be enough for demonstrating the concept. Now, the second thing we need to do here is actually let Zesty platform to identify the EBS volumes out of all the disks you have in the system and make sure that we understand this is a Zesty disk. This can be grow and shrink. Now, in order to do this, in the snapshot field, in this search field, we're gonna type in Zesty disk. And as you can see, AWS will translate this to a snapshot ID. If you're using any provisioning tools, Ansible, Chef, Puppet, whatsoever, you can find the snapshot ID in our documentation on the website. But if right now we are doing just by doing clicks in the dashboard, it does the autocomplete for us. Now, once we have this set up, and we will get additional device, which will be dev SDB on the instance. We want to make sure that we format this block. We want to make sure we mount it somewhere. We want to take some path, for example, /data, and mount the disk to this folder, and also make sure that once the instance will be restarted, this will mount the disk back. So to achieve this, let's get one step back to the user data script And as part of the agent installation, we provide very simple bash script. We use the xinfra, which is the folder where we install the infrastructure monitoring agent. And we have a script called zmount. Now, again, what it does, formats our dev SDB device, and it can also mount it to a particular path. For example, let's take /data. Let's go ahead, give it some name. Let's call it webinar demo. This one is also fine. And let's provision the instance. Now, while we are waiting for the instance to come up and be ready for usage, let's get back for a second to the Zesty dashboard and see what are the capabilities you can get from the dashboard. So first of all, as we mentioned, the monitoring and the visibility side, once the instance will be up and running, we'll see the disk utilization here in this screen. Meanwhile, we can see the monitoring tab, which actually provides value by giving you real visibility into your existing EBS volumes. We have integrations with Slack or Microsoft Teams. Now, if you think about this as a standard monitoring tool, this also have a remediation approach inside. What do I mean? Basically, once any of your volumes in any instance will reach an 80% threshold that you can configure here, you will not just get an alert. This is boring. You will also get a recommendation and a one-click remediation that you can use and approve and actually add more storage automatically. And just by approving this, Zesty will take care of taking a bigger disk and extend your EBS volume on AWS, and also take care about the file system that is running on the server, whether it's ext34, BTRFS, XFS, any types of the common file system we can handle. And this will happen by one click from Slack notification. Now, let's get back to the console. Let's see. All right, we have an instance here up and running. Let's connect inside. EC2 user. SSH by the side. Perfect. All right, for the demonstration purposes, I will also install Tmax. I want to split the screen and show you a couple of things in parallel. So this will be very helpful here. All right, so let's start from very basic command. Let's start from the df command to see what's the usage and what are the file system we have in the server. We see the root volume, which is 8 GB in size, like we created it in Amazon. Also, we see the /data, which is 15 GB in size. Now, let's also run this in a loop. Let's use a watch command to see how the file system size is changing. Let's specifically focus on /data because this is what we really want to see. Also, in parallel, we wanna get another screen here and do lsblk. Actually, list all the block devices that this instance have. So you can see here the XVDA, which is 8 GB in size. This is our slash partition, and the /data, which is 15 GB. Let's also put this on a loop. Perfect. And we see absolutely the same picture here in AWS, 8 GB, 15 GB disk, fine. Now let's get back to our dashboard. Let's refresh it for a second and get back to the file system tabs, and let's see what we can get. Amazing. So this is the same picture we see here. Our root volume, we see the link to our instance, which we call webinar demo. We see it's in Virginia, / data, all our file systems here. And here you can see that the / data is actually configured to be a Zesty Disk. You can see the real utilization. You also clearly see the monthly cost of each and every disk that we just provisioned. Very straightforward. You already aware how much you will be paying end of the month. So this is in terms of the visibility. Now, what we want to do next, we want to start using the disk. We're going back to the server. Let's switch to /data folder. Actually, the disk itself is 15 GB, and I just want to spare all of our time and do some small hack here and already allocate some space. Let's just, from the first minute, let's allocate 5 GB file, just spare the time and of growing the disk. Next thing we want to do, we want to start writing some random data into the volume, and let's see how the disk actually reacts to changes and what will actually happen. So we are going to use the dd command to create some sample file with random data. This, as you can see, the size of this file will be 20 GB, which is bigger than the volume we have right now. It just cannot fit in. Now, as I mentioned, the best practice here would be in production, taking some space which is suitable for at least 12 hours of your application, first 12 hours of your application lifetime, because again, you don't want to be super tight. Even though if you will take more space than really needed, again, the system will take it from there and shrink your disk back if you took too much. So again, just as a best practice, it would be to separate the OS from the real application data and take enough space for the first 12 hours, and then let the disk go up and down according to the real application needs. Now, what we're seeing here, just to make sure we are on the same page, we see the file system, the / data that we already allocated around 7 GB of space here. It's almost 60% occupied. Now on the right, we still see our 2 disks that are attached to the instance. The best part here is that we can see also the same thing here at the dashboard. If we will extend the line of the file system, we see the account that the file system is created on. We see the instance, we see the running platform, all the disks, and also the usage metric. Now here we get a clear visibility into how much disk space we provision. It's 15 GB, the blue line, and the usage. We also see that we started writing data, so the write bandwidth is going up. And take a look what happened. Actually, when we occupying more and more space, take a look here. We got additional disk of 15 GB that just joined a couple of seconds ago. And look here, the file system is now 30 GB, and we are back to a safe side. We are back to 40% in usage. So actually, by pushing more data than we can store on one single EBS disk, the system reacted to the spike in usage and actually add another disk to our instance. Let's see, we see the same clear picture in AWS. Another EBS volume just joined the file system. Let's refresh here to see the same picture here. Let's give it a hard refresh so we can see the list of the volumes here as well. Let's take the /data. Okay, so UI is taking around 1 up to 2 minutes of cache behind the scenes. Again, because we want to absolutely separate the performance of the dashboard and the backend systems. So we replicate the data that we represent on the dashboard. So there is no impact of the dashboards and users that are using the dashboard on the backend. So this takes around a minute to really represent the current state. Let's see, it's still refreshing. Oh, okay, perfect. Now we see that our file system right now is 13 GB. We see the block devices here. We can also see that the file system is actually jumped from 15 GB to 30. You can extend this as well and see this happening. Also, we show all of the events while they started and happened. So at this point, the system realized that there is too much capacity allocated and actually added another disk into the system. Now, actually, this is how Zesty Disk can immediately grow without the lock of 6 hours. We can add more and more disks or expand existing disks in the auto-scaling group to provide you the storage immediately once it's needed. Now, the opposite side, by scaling down, is actually more tricky. Instead of just, reacting very fast, our AI algorithms learns the utilization and the pattern of usage of your disks. Now, because this instance was provisioned just a couple of seconds ago or minutes ago, we don't have any historical data that we can rely on or take some smart decisions. So actually, the AI can't do any smart actions right now. The first shrink action you should expect to happen is typically around 24 hours after the instance was provisioned. Again, because we want to be on the safe side and make sure we are not breaking anything, and find the ideal time when we can shrink the file system back, and again, just for be on the safe side, the AI will not take any actions right now. So I invite all of you to join us again in 24 hours. I'm just kidding, no. What we will go and do here at this presentation, we'll bypass the logic, all the backend, and just ask our backend behind the scenes to remove one of the disks so we can shrink back and show how this is happening live in our environment. And also, we're gonna start more writes here on the disk to see the real magic happening. So, getting back to the console, we can see that we allocated 50% out of the capacity we have right now in the file system. Oh, it's actually because it continued growing. We are added one more disk. The file system already grown more. That's fine. And let's see. We have here the two files we just created. Let's remove both of them. We want to make sure that the disk is back and we released all the storage we just allocated. As you can see here on the top, we are back to 1%. Nothing on the disk. Now, what we are going to do, we're going to ask our backend to shrink the file system back manually right now, just to demonstrate how this happens in real world scenario. And also, I think we will start something like this. We will add, let's say, 5 more GB to the storage. We'll keep writing to our disks while the backend is taking care of removing one of them simultaneously behind the scenes. Let's give it a couple of seconds to catch up. Okay, so as you can see here on the left, we had a 45 gigabyte file system. Now it's 30. And look here at the amount of disks that we have attached to the instance. And again, we are still writing data on the file system. The writes are running right now in live. Let's give it a couple more seconds to safely identify this is no longer needed. And let's see. So right now we are back to 30 gigabyte disk. Again, because we did it right now for the demo purpose manually, we just removed one of the disks while the file system is still writing data in real time without any interruptions. Let's go back here. This is a previous snapshot. We have 3 disks here in the instance. And actually, we got back to 30 gigabyte here. Let's also refresh our metrics here. All right, so as you can see, we got to a point where our file system was 30 gigabyte, and it's again, because I forgot to finish the writes to the disk, we extended it even more to 45 gigabyte, and then back to 30. And this concept is actually being monitored 24/7, monitoring your file systems and adjusting them right in time to your application needs.
This is awesome.
Thank you, Ido.
I'm still surprised every time I see this.
All right. Actually, I will give you a bit more details back on the presentation. So currently, we support all the major OS types like Red Hat, Ubuntu, CentOS, Amazon Linux, which is, I think, one of the most popular. So stay tuned for Windows support as well. This is coming soon. I think we're at a good stage to go forward with any questions that may come up from the folks in the chat. Guys, we have many attendees here in the presentation, so we'll try to answer as much as possible. Stuff that is very interesting. Feel free to reach out and ask. Ido, anything?
Yeah, we have a few really good questions in the chat. So someone asked, the same features of Zesty Disk is available with NetApp untapped flex volumes as well. So how is Zesty Disk different?
Yeah, an amazing question. So basically, as we demonstrated here, the best thing about Zesty Disk is that we are not taking your data anywhere. We actually utilize the same EBS capability that natively offered by AWS. And the only thing that EBS is really good at is making sure that we actually flip the responsibility. Now, instead of you going and monitoring and managing your file systems and adopt your usage to the cloud, we make this different. We actually use the native cloud tools that you already familiar in using in your applications and make them adjust to your needs. Instead of bringing some clusters or management tools or any auto-scaling groups of instances, nothing else, pure EBS. You don't need to pay extra for any resources or instances that managing all this stuff. We're not using any tricks here, just EBS, the well-known EBS and your application.
Cool, we got a couple more. When disks are added, are the tags copied from the original disks? Is the new disk differentiated somehow from remaining disks using tags?
Yeah, amazing question. So basically, our idea is taking the first disk that you created. By the way, if you remember when we created the instance initially, I tapped the delete on terminate checkbox. Actually, this one is applicable for the first disk we just created. Now, what's happening behind the scenes? We create different EBS volumes from different size, again, to accommodate to the real usage on the server. And all the properties like tags or delete on termination, all these properties are being replicated to all the disks in the group. So they're all absolutely the same in terms of configuration and tags.
Okay, we have someone who asked a couple of really, really good questions. So I'll just ask them one by one because you don't have capacity to really handle all these questions all at once. Are you filling the disks one by one?
No, this is actually, thank you for asking this. Actually, the magic behind the scenes here, let's get back to the original thing that we discussed. When we create one single EBS volume and create our file system on it, basically we have one disk and we are bounded to its performance. Now, when we build the same file system with the same 100, for example, 100 gigabyte size from multiple blocks, we are benefiting from the extra IOPS that we get as part of this disk, because each and every smaller disk have huge burstable IOPS that we get from AWS, and we are writing and reading data simultaneously from 2 or 3 or even 5 disks in parallel. So getting 3 or 4x more write and read speed for absolutely the same price, because AWS is in GP2 and GP3 charges us just based on the size. So we can leverage more storage and leverage more read and write IOPS for absolutely the same price.
Awesome. What happens when you need to detach a disk that has data on it? Will there be a performance degradation when data relocates? That's a really good question.
Yeah, that's amazing. So as we discussed earlier, and that's the main reason why we don't just, do an auto-scaling group, like going up and down immediately. That's not because we are not able to do this. That's because actually, because the data is being spread across multiple EBS volumes, so when getting back and deleting some of the data, we still have some blocks that might be on the disk that we are going to remove, and we don't want to lose data. Now, what's happening behind the scenes, because we monitor both the capacity, the allocated capacity, and the IOPS, read and write IOPS on the disks, the AI actually learns the pattern of each and every disk of each and every file system, and identifies the best possible scenario and best possible spots where we can do the shrink. Why? Because as the smart guy that asked this, once we want to detach this small 20 gigabyte, 10 gigabyte volume out of the group, we need to make sure that all the data blocks that are still there will be redistributed across the other disks in this cluster. So yes, once we do the scale down, we are making sure that this is a safe time to do this on lower usage and lower writes and reads times, and then we take the action. Now, this is also something interesting that we hear from our customers, that, okay, we don't see the disk is shrinked at a particular time after 24 hours, for example. This can be because the AI see that there is so much read and write types right now, so we will prioritize the scale back, because this action is going to save money, and we don't want to impact the performance, so we'll find a great time to do this while the disk is idle.
All right. How are you dealing when reaching the limit of EBS volumes that can be attached?
Perfect. So by default, AWS allows us to, and again, it's a guarantee limit in the documentation. It allows us to attach up to 20 EBS volumes to a single instance. Now, this is quite a lot because each and every instance can be, if I remember correctly, 16 terabyte inside. So it's a huge one. Now, instead of just adding more and more EBS volumes into the existing file system, we actually take two main operations here. One is extending the existing disks. This is number one. And number two, adding more. Now, the best case scenario here is when the AI is always aimed to be at around 2 or 3, sometimes 4, but most likely 3 EBS volumes per file system. So we leverage all the available slots for unexpected growth or any spikes in demand, so we can easily attach more and more storage. But most of the time, 20 slots is more than enough.
Do we support GP3?
Amazing question. Basically, as any technology out there, the GP3 is being just very recently released by AWS. Now, the thing that we saw and also our customers complained about is the performance. Basically, if you look at the pricing, there is a difference of around 10% in US regions. The GP3 disk is cheaper, but it's also it also impacts the performance of the EBS disk. So actually, the best part here is that we do the homework in our labs, testing out any new available features out there that are released by AWS, testing them here, making sure that we really match and understand that the spec of this offering is very it is a reality and actually matches the real performance on the instance. And once we see this is not the truth, we actually postponed migrating to GP3. Now, the best part here is once all of this performance issue will be sorted out and we will see that the GP3 is widely adopted, our customers will be migrated to GP3 seamlessly. And actually, even if AWS will release more like GP4 or anything else, Zesty Disk, you just don't need to think about this. We will just continue upgrading you with the latest developments that AWS offers and update you seamlessly behind the scenes to newer offerings absolutely automatically.
All right, we got a couple more. Can the disk size be monitored using CloudWatch so that I'm alerted if the dynamic size has become too large? And can each EC2 instance disk be reported as part of AWS Cost Explorer?
So I will start from the end. In Cost Explorer, you can build any custom report that, in terms of the spend and how much actually you paid for your provision disks. So this is just a matter of how you play with the report and build it the way that makes sense for your ongoing management and making sure that you're on top of the costs. Now, actually, this is something that we constantly do in Zesty, is listening to customers' feedback and things that they want to get. Currently, we don't have an integration with CloudWatch or not reporting this metric to CloudWatch. If this is something that you guys will require and you love to use CloudWatch as your monitoring tool, this is I think this is a very simple task for us to do.
All right, I think this is the last one. Does this require the addition of new disks and then Zesty move all the data to it, or can existing EBS volumes be used to scale?
Amazing. So let's talk about how you can already use what you saw in the demo in your organization today. So first of all, I will start from something that is also important to mention. All you saw, the dashboard is self-service. You can go register in our website, create an account, add your AWS credentials, because we use an IAM role to do this manipulations and create more disks in AWS. Now, we saw how we provision a new EC2 instance from scratch. This is simple. For existing instances that are there up and running, so the first value we can provide is by installing the monitoring agent, getting a visibility into how much you really use the provision storage. We see a huge waste in EBS volumes just due to people tending to over provision and take larger volumes than they need. Now, the first step would be to install the agent, get visibility into how much you can save. And by the way, this is part of the dashboard KPIs. You will see how much Zesty can actually save on your existing volumes. And the next step would be is really migrating your data. Now, unfortunately, we can't take the existing disk, which is large and configured with some old-fashioned XFS, EXT, or so on. The first step would be to attach a Zesty Disk and migrate your data to this, and restart the application so it can use consume the same data from the same mount point. And since this, you never need to touch this again, and let Zesty to manage your capacity and adjust to your application needs.
All right. If there are no further questions, I think this is it. So thank you very much, Alexei. This was super insightful, super beneficial. I hope, guys, you really enjoyed it. We're making DevOps dreams come true, so feel free to reach out. Thank you all for joining, and until next time.